Hi everyone, today we're going to talk about convection, which is another type of heat transfer that has a lot to do with density. And I'm going to be introducing it by reading this reading that comes from our textbook. Convection. If you put a couple centimeters of water in a metal pie pan and support it over a candle, you can slowly heat the water. The energy from the flame will heat a small area of the pan and the water directly over the flame. So as you can see, the water that's directly over this flame is going to start to heat up. A small mass of water will heat up. The question is, what happens to the hot water? The water expands as the water particles gain kinetic energy and push further apart. The expanding water is less dense than the surrounding water. The warm water rises. So we know that the faster molecules move, the hotter they are. And when those molecules are moving fast, they start bumping into each other. And when they bump into each other, they start to spread out more than they were spread out before. And when there's less matter in a volume, that means that matter is less dense. So now these air molecules or these water molecules are spread out from each other and they're less dense than the other water molecules. So the less dense water starts to rise because we know that things that are less dense like to float on top of things that are more dense. When the warm water reaches the surface, it spreads out. Water at the surface cools because it is no longer near the heat source. The energy can transfer away from the water to the environment. So again, the water that's close to this candle is starting to heat up. That hot water is less dense and it rises. But as it rises away from the candle, now it's away from the heat source and it starts to lose its heat and it starts to cool down because it's away from the candle and close to the atmosphere. When the cool water reaches the edges of the pie pan, the water is dense. It flows down the sides of the pan, across the bottom, and back towards the center of the pan. As the water nears the hot metal, it begins to warm again. The hot water rises to repeat the cycle. So, as the hot water gets away from the candle and starts to cool down, those water molecules aren't vibrating as fast and they're not pushing off of each other as much, so they start to get closer together. So now there's more molecules and more matter in the same volume, but now it's more dense, so that colder, more dense water starts to sink because we know that things that are more dense are going to sink below things that are less dense. And as that cold water sinks, it becomes closer to the candle, and the candle is the heat source. So now the candle starts to heat up the water once again. Those molecules start bumping into each other and vibrating faster, becoming less dense and rising. As they rise, they're farther away from the candle. They lose energy, become more dense, and sink back down. So this is a constant cycle. The movement of water in the pan driven by a localized heat source is convection. Convection happens only in fluids. Gases and liquids are both fluids because they flow. Fluid near an energy source heats up and expands. The hot fluid becomes less dense and rises. The energy in the particles of hot fluid is carried to a new location. As the fluid cools down, heat energy transfers away from the fluid. It cools, contracts, making it more dense. The cool fluid flows downward again. The mass of fluid flowing in a circle is called a convection cell. Air is a fluid. Air can heat up, causing it to expand. When air expands, it becomes less dense. Less dense air will rise in the atmosphere. In the next few investigations, we will see how the process of convection helps redistribute water around the planet and affects all types of wind, from gentle breezes to powerful, dangerous storms. So I want to talk about how this has to do with how our earth is heated. So we know that the main source of heat to the earth is the sun through the process of radiation. But what you might not realize is that the earth acts like a giant blacktop, and it absorbs all the heat from the sun. And the earth takes that heat from the sun and re-radiates it out to the atmosphere. It's called re-radiation. And this process of re-radiation actually heats the earth and the atmosphere more than the sun itself. So that's important to remember. The sun heats the earth absorbs all that heat and re-radiates it to the atmosphere. And that is the main source of heat for the entire atmosphere. So what happens is all the air really close to Earth's surface is much hotter than the air up in the higher icy mountain peaks. So that heat that's really close to Earth's surface is hot and it is less dense, so it rises in the atmosphere. And when we get up to those icy mountain peaks, so think about the mountains and how they're so icy and it's usually snowing up there. That's because those mountain peaks are far away from the main heat source of Earth's surface. So when the air gets up to the upper atmosphere, like those icy mountain peaks, that air is then colder and it is more dense and it sinks back down. But what happens when it sinks back down? The earth warms it again, it becomes less dense, and it rises. And that cycle is what causes wind and many other of the processes that happen on Earth.